Welcome to the video lecture series of electronic devices. This is lecture number 5. In today's lecture, you are going to study about atomic structure and Bohr's theory of hydrogen atom. From the atomic structure, you are very well aware, but to begin with, let us take a review of atomic structure, then we will continue to the Bohr's theory of hydrogen atom. You know that the matter consists of atoms, and atomic structure refers to the structure of atom comprising of nucleus in the center, in which protons and neutrons are present. Protons are positively charged while neutrons are neutral in nature. Electrons, which is having negative charge, keeps revolve around the center of the nucleus. You have studied about atomic structure in your school days. From this particular diagram, you can review the concept. Like here you can see that nucleus consists of neutrons and protons, and electrons are revolving in the orbit which is around the center of nucleus. Means nucleus contains protons and neutrons, and protons are positively charged. The charge on a proton is 1.6 into 10 raised to the power minus 19 coulomb. Neutral atoms have equal number of protons and electrons. These two numbers are same in the case of the neutral atom. Protons and neutrons are held together by a strong nuclear forces. Electrons are negatively charged, and the charge on an electron is minus 1.6 into 10 raised to the power minus 19 coulomb. Its mass is 9.1 into 10 raised to the power minus 31 kg. Mass of proton or neutron, this is 1836 times m. Practically entire mass is concentrated in the nucleus itself. In neutral atom, as I have told you that number of electrons is equal to the number of protons, and size of an atom is of the order of 10 raised to the power minus 10 centimeter. What is atomic number Z? Atomic number Z refers to the number of electrons or protons. There is one more term you have studied, which is the atomic mass number, and this is represented by A. Atomic mass number is equal to the number of protons plus number of neutrons. Accordingly, there is one more term which is known as the atomic weight. What is atomic weight? It is the actual weight of the atom, and numerically it differs slightly from atomic mass number. So it is not necessary that atomic weight and atomic mass of any atom is same. Slightly they may differ. So these are the some of the terms and data which you have already studied, but I have told you just to review all the concepts, so that in a coming class, whatever you are going to study, you will be able to relate each and everything. Now, let us start with the Bohr's theory for hydrogen atom. What is Bohr's theory and who is this Bohr? Bohr, the name of scientist who was able to derive the formula for the hydrogen spectrum using basic physics, the planetary motion of atom, and some new proposals. So let us begin and how to derive the formula which have been given by the Bohr's by taking various assumptions as well. Since we are deriving it for the hydrogen atom, you know that a hydrogen atom consists of a single proton in the nucleus and an electron moving around the nucleus. Here in this particular diagram, you can see that a single electron is being shown which is moving in a orbit. This is the electron. Bohr's theory of hydrogen atom is based on the certain assumptions. What are those assumptions? Let's study one by one. First is electron revolve around the nucleus in these stationary orbits only. Second assumption is the Newton's second law force of attraction on the electron by the nucleus can be written into this form. But how this equation is being written, let me tell you. You can see in this particular diagram, this is the nucleus. Electron is moving in the orbit around this particular nucleus. Here the outward centrifugal force, this outward centrifugal force balance the electrostatic force of attraction, that is Coulomb's law, towards the nucleus. So when these two forces balanced each other, so you can write down this particular equation. F is equal to mv square upon r. This is because of the centrifugal force. And 1 upon 4 pi epsilon naught into E square upon R square. This is because of the Coulomb's law. You know that Coulomb force can be written as K Q1 Q2 upon R square. Here Q1 and Q2 both is equal to E. So Q1 Q2 is equal to E square. And what is K? K is 1 upon 4 pi epsilon naught. So this is how this particular term arrives, and you can equate these two forces. So this is how we have mentioned is at the equation number 1. Moving ahead, third assumption is only those orbits are possible for which orbital angular momentum of electron is equal to an integral multiple of h upon 2 pi. Here h upon 2 pi, here h is the Planck's constant. You have already studied that the h is Planck's constant. So it can be equated as mv into r is equal to n into h upon 2 pi. This is for those orbits where angular momentum of electron is equal to this is the angular momentum, and it is equal to the integral multiple of h upon 2 pi. N defines the number of orbit. It may be 1, 2, 3, 4. Next assumption is as long as electron stays in its own stationary orbit, there will be no absorption or emission of energy. Obviously, whenever electron is in the same orbit, it is not moving to the higher orbit or moving to the lower orbit. There is no absorption or the emission of the energy. Next point is electromagnetic radiations are emitted. Point to be noted. If an electron jumps from stationary orbit of energy E2 to the another stationary orbit of energy E1, where E1 is less than E2, energy level of E1 is less than that of E2. It means whenever an electron is moving or jumping from higher energy level to the lower one, it emits the energy. So that can be written into this equation. Here E is what? E2 minus E1, which is equal to H into nu. And this is being written as equation number 3. Here, what is our objective? Our objective is to derive the radius for that particular hydrogen atom and how it is being related with the other parameters. So using both the equations, radius of stationary states can be written as Rn is what? Epsilon naught h square n square upon pi m into E square. Just you have to substitute the first equation where you have written the centrifugal force is equal to the Coulomb force, and the second where orbital angular momentum of electron is equal to the integral multiple. So by utilizing those two equations and rearranging the terms, you have written Rn is what? Is the equal to the epsilon naught h square n square upon pi m into E square, where the value of k is 9 into 10 raised to the power 9, epsilon naught 0.0088 into 10 raised to the power minus 9. H is the Planck's constant. It's a 6.6 into 10 raised to the power minus 34. M is the mass. E is the charge. So you must remember the values of all these constants, because sometimes in numerical all these particular values may not be given to you, but you have to utilize this while getting the final answer. So n is equal to 1 is the case when you are calculating it for the smallest orbit. So if you substitute n is equal to 1 and put all the values of these constants epsilon naught, h, m and e, then you will be getting n is, since n is 1, so r1 will be equal to 0.529 into 10 raised to the power minus 10 meter, or you can write it as 0.529 Armstrong. This is the radius, and if you are calculating the diameter will be obviously what? Twice of radius. So this will be what? 2 into r1, where r1 is being given. So if you calculate, it would be approximately 1 Armstrong. How to calculate the orbital energy of an electron revolving in nth orbit? So when you have to calculate the orbital energy of any electron, you have to consider these two terms, kinetic energy and potential energy. So the total energy will be the sum of kinetic energy and potential energy. And kinetic energy, you know, it can be written as 1 upon 2 k E square upon R. E square comes from Q1 into Q2. And potential energy, you can write it as K Q1 Q2 upon R. Here Q1 is E and Q2 is minus the charge on the electron. So this is what this term is coming out as, minus K E square upon R. While kinetic energy is 1 upon 2 K E square upon R. So En, orbital energy will be what? Kinetic energy plus potential energy, and simplify it, you will be getting En is what? Minus 1 upon 2 K E square upon R. This is what the equation of orbital energy. Here you know that E is the charge on the electron, K, the constant, its value is already known. R, you have already calculated the radius in the previous calculation. So now you can calculate the orbital energy for different orbits by substituting the value of n is equal to 1, 2, 3, so on. So now substitute the value of n. En will be what? Minus m into e raised to the power 4 upon 8 epsilon naught square into h square into 1 upon n square joule. This is now when you are substituting the value of R from equation number 4. Here you know that all the constants m, e, epsilon naught, h, substitute all the constants and simplify it. You will be getting En is what? Minus 13.6 upon n square electron volt. See, here the unit is electron volt, and the relationship between electron volt and joule is 1 electron volt is equal to 1.6 into 10 raised to the power minus 19 joule. Here you can see that there is a sign, negative sign. What does it representation? What does its significance? This negative sign shows that electron is bound to the nucleus by attractive forces, and to separate it out from nucleus, energy must be supplied. Means negative sign shows extra energy need to be given, then only there will be a change in the orbit. So by putting the different values of n, 1, 2, 3, 4, you can calculate the values of En. That has been summarized into this table. When n is equal to 1, means for kth shell, E1 is what? Minus 13.6 electron volt. For n is equal to 2, that is for L shell. E2 is minus 3.4 electron volt. For n is equal to 3, it is 1.51. So on, you can calculate for any value of n. But when you are calculating for the nth level, you can see this term of n is in the denominator. So when n is infinity, this particular energy level, this value will be 0 electron volt, and that is the limiting case, you can say, in the case of energy level representation. Diagrammatically, it can be represented into this form. You can see over here, for n is equal to 1, the energy level is minus 13.6, for 2 it's minus 3.4, for next level it is 1.51, and so on. When n is infinity, which is the limiting case, the energy level is 0. So this is how the energy level can be represented in an isolated hydrogen atom. So I hope it must be very much clear to you how to calculate the energy level En by putting different values of n and how to represent it diagrammatically. In today's class, I have completed two topics. One is the atomic structure and second is the Bohr's theory. So I hope both the topics must be very much clear to you. And topic for the next class is excitation and ionization of atoms and collision of photons with atoms. Thank you so much.